This conference will now be recorded.
Hi guys, good evening, good afternoon if anybody has joined from Europe side. So this session is all about Cisco AST access, Cisco software defined networking access, which is all about how do you actually see our future campus network infrastructure. But before that, I want to show you that from our company, from Esturi Technology, what do we do, what kind of trainings we deliver, and if you or your friends are interested in future, want to join any trainings, you can definitely come back to us. So let me just go through our website and show you that. Just give me a moment. Okay. So basically, we are into trainings. We do deliver trainings in Cisco environment. I mean, almost all Cisco certification. Let me go through the list of courses. So we do deliver trainings on the wireless. We deliver trainings on Meraki wireless as well. We have Cisco AST access. This is the second batch what we are actually delivering training on Cisco AST access. Cisco AST WAN we are planning in the future. If anybody is interested to learn more on specific, let's say, for example, Cisco newly introduced wireless LAN controller, which is C9800. We do have a special or the separate training module for that. If anybody is interested to learn about wireless troubleshooting, including, say, for example, packet capture analysis, how do you do troubleshooting? How do we use different wireless, how do you use tools, for example, eCow site survey tool or
Can you hear me okay now?
Hi, yes.
All good, right?
Yes.
Yes. Okay. All right. So there are many modules what we deliver as a part of our trainings. If you want to go for expert level, we do have training on expert level. If anybody want to get expertise in Wireshark, we have Wireshark trainings as well, where you can go through the Wireshark. How do you create IO graphs? How do you capture packets? How do you do, let's say, for example, wireless packet captures, wired packet capture? How do you actually troubleshoot network with the help of PCAP file and all? So these are all trainings we deliver. If anybody is interested in your friend circle, or if you are interested in any specific module, let us know. Anybody has worked on Cisco AST access so far in this particular list? No? All right. So not a problem if anybody has in this particular participant list. Anybody has worked on heard about Cisco AST access, guys? Rahul, Mrunal, Karthikeyan?
No, sir.
So basically, this is latest technology in Cisco for campus network. Now, when I say campus network, and what is it for you? So before learning Cisco AST access, we will try to understand what is intent-based networking, okay? So what does it mean by intent? So before even that, you might have heard about all these buzzwords, right? Automation, then you got STM, then you got Python programming, you got other buzzwords like, for example, Linux as your requirement for network engineer to learn, Yang model, Ansible, machine learning, telemetry, and then you got intent-based networking. So basically, everybody, not only Cisco, all vendors are actually talking about intent-based networking. So in a normal language, what is intent? Intent is, for example, let's say I want to drive a car and I want to reach to a particular destination. So what do? First, I'll collect the key from home, I'll actually, let's say if there is no fuel in the car, I'll go to the gas station, I'll fill up the fuel, and then I'll start driving. So my intent is to reach to the destination, but to reach to the destination, I'll have to take the car. If there is no fuel, I'll have to go to the gas station, I'll fill up the fuel, and then I'll have to reach to the destination. So my intent is to reach. For that, whatever is required, these are all activities. In a networking language, or in, let's say in Cisco networking language, when we talk about intent-based networking, it's all about, for example, let's say today I'm hosting free webinar class, and I'm sitting in my office, and I'm planning to have this free webinar class. I'm, let's say, at 7 p.m. IST. Now, before, if I just say that to network infrastructure, or let's say a controller, this is my intent, and you need to configure all my network infrastructure for hosting this webinar. So for example, I want to configure QoS as an end-to-end on all infrastructure. I want to give marking for my voice traffic. I want to give marking for my video traffic. So all these background operations or the activities which will be done, that should be done automatically just by defining what is my intent. So to do that automation, or to actually execute those all activities, to just host my webinar, I need something which can actually push that automation or to execute that automation. And that's nothing but my DNAC controller, who does everything just by defining intent into DNAC. And then DNAC does the rest of the things, which includes your configuration of, for example, your devices, your controllers, your access points, broadcasting SSID, and everything. So that's actually intent. Now, is intent only specific to Cisco? So it's not. So I explained about what is intent. So what other companies say? So Cisco talks about automation. Cisco talks about how do you get consistent network performance or intuitive network across infrastructure. And that's nothing but intent-based networking. What Veriflows, that's another company. Again, they work on intent-based networking. They are also talking, but it's kind of a same motto, but a different language. So intent comes from business objective and what business requires, and then you actually implement into the network infrastructure. What Huawei says is again the same. It's a closed loop automation and network intelligence. What Glue Network says, what Apstra says. So these are all companies who actually are working on intent-based networking, who are actually developing SDN infrastructure, who are delivering SDN into the market. Cisco is a market leader company in intent-based networking, who does automation, or let's say SDN framework in all architecture, which includes your WAN. All right. If you have no questions from that, if you don't have any question, please guys keep yourself on mute so that there's no noise. If you have questions, please unmute yourself and you can start asking questions. As one architecture, because we are just trying to understand where does ST access fits in, right? In terms of different architecture. So let's say one of the technologies WAN, or one of the architecture is WAN. Second is about DC, which is data center, and the third one is about LAN. So if I consider three different architecture in WAN technology, in SDN framework, we call as SD-WAN, okay? And in data center, the software defined technology, which is, Cisco specific terminology, is called ACI. And in LAN, it's called SD access. So we are actually focusing on this particular technology, right? Sorry. we are talking about this particular technology. Now, when we talk as SDN framework and we say that it's a controller-based environment, in SDA access, there are 3 controllers. So we manage, for example, in SD-WAN, there is vManage, then you got vSmart, and you got third controller as vPoint, right? However, in data center, in ACI, you got Epic as a controller. And in SD access, it's called DNAC. So when we are going to start our batch, or when we actually go through the entire training, DNAC as a special topic, we will be going in depth about what is DNAC, okay? What is DNAC? We'll try to understand more about DNAC architecture, because it's very important to know how this server actually has been built, what is underlying platform, how do we form cluster, because it's not your traditional way of forming HA with 2 appliances. It's a 3-node cluster. So why do we need 3-node cluster? We will go in depth about that. And DNAC has got 2 different planes. One is your NCP, network control plane, and second is about NDP. So NCP is actually covering automation, okay, and NDP is actually talks about or covers assurance. So we will go in depth in a DNAC when we are actually starting training. But just to get an overall idea about what SDN and which architecture has got different, kind of which SDN framework. So we are not going to talk about SD-WAN in this training, or we are not going to cover anything about data center. But yes, whoever has worked in data center, especially on ACI with Epic as a controller, they will be very comfortable when they are learning SD access. All right. So this is something I wanted to give you overall idea about. Now, when we actually talk about why do we need SD access, before that we will have to understand at what challenges we come across in the traditional infrastructure. So in a traditional infrastructure, if you see this is the traditional infrastructure where you get, for example, core switches, you got access layer switches. So your layer 2 network, or the layer 2 demarcation, I would say, is, is here, right? So this is your L2 domain. You got all SVIs created here. So whenever someone from, let's say, VLAN 30 is trying to talk with VLAN 40, or let's say there is a ARP request has been sent from, I think it will be good to have properly built packet, isn't it? So this is my payload, which is, let's say I'm pinging or whatever data I'm sending across. So let's consider I'm pinging. So I'm pinging 22.22.22.1. So ICMP is my payload. My IP address of destination is 22.22.22.1. My source IP address is 11.11.11.1. My source MAC address. So for example, in this case is AAA, and the destination MAC address, I don't know. So basically, because I don't know, I'll be sending based on my ARP request and reply through a default gateway. My destination MAC address will be EE0, right?
Now, when the packet reaches to core switch 1, core switch 1 sees that, okay, the packet has come with the destination as 22.22.22.1. What will core switch sees? The core switch will actually look for a routing table, right? So this is the first thing what L3 functionality will be there. So it will check, okay, where do we reach 22.22.22.1?
This conference will now be recorded.
So now when the packet reaches to core switch 1, it will check for the routing table, and it will try to see like how do I reach to 22.22.22.1, right? Now, since core switch 1 knows that to reach to 22.22.22.1, I should reach via this interface. So for example, this interface number is 9. So it will send that before sending that packet, it has to build that packet with the MAC address. Now, since the packet has already been reached with this L2, sorry, let me highlight that. This L2 information, it will strip off this and it will try to rebuild the new L2 header. So your source will be same, destination would be same, your payload will be there. Now my MAC address table, right? So since I don't know, now my source MAC address will be port 9 MAC address. So for example, port 9 could be EEE, let's say 3. And what will be my destination? So I don't know my destination. So my core switch will send ARP request, right, to the outgoing interface, and it will try to get the MAC address of that. So for example, since we do not have any L3 device in between access switch 4 and core switch, so the packet arrives to access switch and it knows that, okay, it will check for the MAC address, where that destination is. So basically your layer 3 switch, which is core switch, knows that my MAC or let's say that IP address is actually been connected to port 9. So it will try to get the ARP reply from VLAN 40. And then since core switch 1 has got ARP table built, right, against the MAC address and the IP address, it knows that, okay, the MAC address for VLAN 40 is connected on port 9. So it sends out that it builds the L2 header. So it gets the MAC address of 22.22.22.1. So for example, 22.22.1, the MAC address is, sorry, let's say B. So it gets that MAC address here, B, and send that packet across to switch 4. Now switch 4 sees, okay, B is connected to port 1. It sends that packet down. Now it knows that, okay, this is for me and this is my MAC address. So basically it strips off this complete and it checks my data, which is my ICMP. And then it sends a reply back to to the actual source as ICMP reply. So that's how your ARP or your data packet travels in the traditional network. But what happens into the SDN network? That's really a kind of something we need to basically understand, and then we'll see the difference between traditional network and the SDN network or SDA access. So let me now, here we are not going to talk any, sorry for tilted line. So this is, let's say this is one of my branch, and I got multiple access switches. In SDA access, by the way, this switches where the endpoints are connected is called edge switch or edge devices, fabric edge. So I'll consider this as FE1, FE2, FE3, FE4. And I got a host connected here. I got host connected here. And now this, instead of your, I would say, host switch or distro, you have got, for example, this is what you got connectivity, right? All right, sorry. So this is how you got a connectivity. So this is your, in your ST access network, let's say this is underlay switch. I'll come to this point, what is underlay and what is, overlay. But for now, just consider this as your underlay switch. Now, when we are sending packet, again, the same scenario, 11.11.11.1, and this is 22.22.22.1. Now, in your classical network, so this network, we saw that these all ports are trunk port, right? All uplinks are trunk. So that's why we said this is my L2 domain. Now this ports, since it is configured, it will participate in STP election. If there is a redundant path, one of the port will be blocked. So it's a traditional layer 2 network where you cannot use two ports at same time in between two switches directly connected. One of the port will be blocked if there is no ether channel, right? Now in SDA access, these ports are L3 port. All ports are L3, by the way. Now you will have a question, how can I extend my L2 frame then? How can I send it across my L2 frame here? Because yes, these are all L3 ports, so it's a complete routing. So this is my L3 domain with, let's say, IS as a protocol running in between. Now, this is where in your ST access, additional protocol has been introduced, which is called VXLAN. Now, if we take the same example of this particular host one, okay, if this particular host one want to reach to host 2, how does packet goes? Now there is L3 in between. What happens here? Where will be the gateway, right? That's the question. So all fabric edges, fabric edge 1, fabric edge 2, fabric edge 3, fabric edge 4, all will have gateways configured here. So for example, for 11.11.11.1, my gateway 254 is configured here, 254 configured here, 254 configured here, 254 configured here. This is called Anycast gateway. I will go in detail about Anycast gateway operation. How does packet traverse across, all those things. But as of now, just keep in your mind, there is no L2 here. It's complete L3. So STP is not coming in picture in this environment. That's where you're actually getting optimal performance. There is no looping mechanism. There is no L2. So basically, if you are already working in ECI, you might be aware about all those things because it's the same. I mean, it's a kind of the same architecture. Here you got different terminologies, but you can correlate those here with the terminology which has been used in the data center. Now for here, let's say I want to send packet to host 2, which is 22.22.22.2. So again the same, right? So ICMP. Then I got destination IP address. Let me ICMP and let's consider destination IP as 22.22.1 and source as 11.11.1. Now what will happen, because I don't know the I have to build the L2, isn't it? But in L2 I don't have destination MAC address. So it's the same thing. Again, I have to build the MAC table. So for that, or L2 headers. So to do that, I'll again have to have a ARP request. Now, when I'm sending ARP request, because it's a different network, I send ARP request to default gateway. Now, my default gateway is Fabric Edge 1. It replies that, okay, take this MAC address. So I take destination MAC address as this and source MAC address. For example, again, let's take same A, and host 2 is B. All right. Now I want to actually, I mean, this is my source MAC address, right? Packet arrives here. Now Fabric Edge 1, because it's a L3, it has to reach to 22.22.22.1. Now Fabric Edge 1 should know how do I reach to, destination IP address. So who will tell to Fabric Edge 1 that I need to reach to 22.22.20.1 via so and so network? Now this underlay is again, it's these are all L3, so all connected via L3 ports, and I need to basically enable with ISIS or OSPF, correct? How do I know 22.22.22.1 is connected to Fabric Edge 4? I don't know. I mean, 22.22.22.1 is not been advertised within this L3 domain. Keep in your mind, it's just a point-to-point connectivity. So this is just point-to-point with /31. Now, how do I know the destination, which is behind Fabric Edge 4? So you will get that information via something called control node. Control node keeps the all IP address details of host connected behind Fabric Edges. IP address, which Fabric Edge it is connected, what's the MAC address of that host. This is called database. All right. So basically, control node knows now host 1 is connected to Fabric Edge 1 with this IP address. Host 2 is connected to Fabric Edge 4 via this Fabric Edge 4. Now when Fabric Edge 1 when the packet arrives to Fabric Edge 1, Fabric Edge 1 should send packet across to Fabric Edge 4. How does it send? So this L3 network is nothing but every Fabric Edge will have a loopback IP address. which is called RLOC, remote locator IP address. So via this RLOC, it knows that, okay, if I want to reach to 22.22.1, I have to reach to Fabric Edge 4, which is the loopback of Fabric Edge 4. And this information, 22.22.22.1, is behind Fabric Edge 4, is given by control via something called Lisp as a control plane or protocol being used in between control node and all fabric edges as well as the border node. I'm not going to talk about border node now, but just keep in your mind, Lisp is being used for a control plane to tell that all these hosts are connected behind which fabric edges. Now, while Lisp fabric edge 1 knows that, okay, 22.22.22.1 is reachable via fabric edge 4, it builds that table. I mean, let's say packet. And I forgot to tell you, when it gets that information about it is behind Fabric Edge 4, it gives you another IP header, which is VXLAN, with the VXLAN header, with the source as loopback IP address of Fabric Edge 1, and destination loopback is Fabric Edge 4. And then you got in between this your VXLAN header, which has got VNI, all information. We are not going to go in detail about that, but yeah, as of now, just consider this as your UDP 4789 detail and all. But the outer header is your Fabric Edge 1 and Fabric Edge 4 IP header. Now the packet via, packet goes and it knows via ISIS it has to reach here. It reaches here, decapsulate this, sees that, okay, packet is for 22.22.22.1. It is behind me. So it strips off this as well and sends that data here. Now you can imagine the difference between your classic traditional infrastructure and SDA access. You have no STP. You have a Lisp as control plane, VXLAN as your data plane to send across this data, and all your ports in between Fabric Edge and underlaid switch is connected as L3 and enabled with ISIS. I hope you understood this particular traffic flow or terminologies which I use, underlay, overlay. Now underlay and overlay we will talk. It's not a new technology as such, because we have been using underlay and overlay terminology since long time. Go to the destination. So for example, let's say this is R1, this is R2, and this is R3. And these are connected via WAN link. Okay, and this middle router is my internet router. So basically, this is my internet. Okay. Underneath this router 1, I got a switch 1, and this switch has got one client machine connected. Same thing on R3. I got this switch here as well, and I got another laptop or another client machine. So this is host 2, this is host 1, this is switch 2. Okay. Now I want to reach over internet, right? So let me erase this.
All right, it's not erased. Okay. So now this is my IP address, for example, 10.1.1.2/24, and this is my 10.1.2.1/24. Host 2 is connected here, right? And my gateway here on R1 for this is 10.1.1.1. And WAN connectivity, for example, this is my 192.168.1.0/24. .1 is connected here, .2 is connected here. And this is another side. I have got 192.168.2.0/24. So .1 is here, .2 is here. Now, host 1 want to reach to host 2. And I have an internet in between. So I'm going to form a tunnel in between R1 and R2. And via that tunnel, because R1 and R2 is reachable via internet, I can form a tunnel and then I can reach out to this particular destination. So when I say I'm forming a tunnel over internet, which technology I'm talking about? Can anybody answer this?
eBGP.
eBGP is the protocol for a routing, but when I say tunneling method,
Yeah, you can use either GRE or IPsec.
perfect. So I'm talking here as a GRE tunnel. Okay. Now I am actually creating a logical interface. Let's say, for example, tunnel 0. And I'm reaching to another side, which is R3. Yeah, I'm reaching on other side logically. So what is my underlay? Underlay is my underlay here is my internet, right? And what is my overlay is my GRE. So GRE is my tunneling method, which is my overlay, and underlay is my internet. So when the packet want to reach, for example, 10.1.2.1, how does packet looks like, right? So let's say my payload, I want to ping 10.1.2.2. My payload is ICMP. And on that payload, I got a GRE header. Right? And this particular payload, so this is my payload. And this payload actually encapsulated inside another IP header or another IP packet. And inside this, this payload, which is encapsulated, the outer header IP address, the source IP address, for example, here, what will be my source IP address here? Can anybody explain this? It's 192, sorry. It's 192.168.1.1. And what is my other side, the destination IP address is 192.168.2.2. So this is my outer header, which is encapsulating my payload and sending across another side. So once this packet reaches here, R3 sees that, okay, ICMP payload is coming for 2.1. So after decapsulating, it knows that how to reach to 2.1. It just decapsulates that packet and comes here. So this is my old, or let's say, we have been configuring GRE since long time as an underlay and overlay technology. Over internet, we are creating a tunnel, and then we are actually reaching out to the other side. So this is underlay and overlay is not a new technology. Now coming back to my SDA access, this is my SDA access. So I'm not going to show connectivity now. Let's say UL1, underlay 1, underlay 2. This is my fabric edge 1, 2, 3, 4. Now these are all my L3 links in between. This is my L3 domain, right? Now, when I say underlay, if I want to reach from here to here, I was showing you the loopback IP address here. Here, sorry. Here and here. Now, when the packet comes to fabric edge 1 and it wants to reach to fabric edge 4, it has to reach via, let's say, UL1 to fabric edge 4. Now, to reach here, my L3 domain is nothing but underlay network. So this is my underlay network to reach out here. And how does it reach? How does that packet get encapsulated? So for example, again, the same example, I got an ICMP packet to reach out to this host 2 here from host 1. How does it get encapsulated? So basically, to reach out here, I'm using underlay, and these loopbacks are actually my source and destination IP address. And when it reaches here, encapsulation, when it goes here, it's actually in EST access is VXLAN. Okay, so reachability through underlay is happening through routing protocol called ISIS. And my data traffic is encapsulated inside VXLAN with outer header IP address as my fabric edge 1, as my source IP address, and fabric 4 as my destination IP address. So that's how packet reaches here via underlay. So basically, I have got VXLAN as my data plane. There is a protocol called Lisp as a control plane. Okay. Now, when fabric edge 1 want to reach to fabric edge 4, how does fabric edge 1 knows, like, I want to reach to fabric edge 4, or how does fabric edge 2 knows that I want to reach to fabric edge 4? Via ISIS. But there is nothing but called control node. So these are control node. So I'm just putting 2 control nodes. So these control nodes keeping the database about, let's say, for example, this host 1 want to reach to host 2, and I don't know where the host 2 is. So fabric edge 1, when the packet reaches here, fabric edge 1 has to actually query that, okay, where do I send this packet? So fabric edge 1 should actually get the information about fabric edge 4 to reach out to host 2. To get the information about fabric edge 4, the control node will actually give that information. So there should be a kind of a request or additional control plane, processing should happen to actually get this data and then send across this packet here. And that is happening through control node. So control node is called as a map server. Okay, and map resolver as well. So control node is like a brain from where I get the information about all these details, and control plane node actually stores the information about all the endpoints. Host 1, like you got hundreds of hosts here. Let's say you got hundreds of hosts. All the database about MAC address, about IP address, let's say MAC, IP, and which fabric edge the host is behind to. So for example, fabric edge 1. So this database is maintained by control node, and the control node gives that information to fabric edges, saying that, okay, you want to reach there, you have to reach via fabric edge 4. So this is the additional node which is there in the SDA access, and SDA access maintains that database. Now, entire configuration of IS for routing, Lisp, you don't have to do anything. You don't have to configure VXLAN. You don't have to configure Lisp. You don't have to configure IS. Everything is done automatically via controller called DNAC. Okay, Digital Network Architecture Controller. So DNAC can be somewhere in the data center who is actually pushing the configuration to, let's say this is one of the branch, and pushing all the configuration including Lisp, IS, VXLAN to all fabric edges for all underlay and underlay switches, and then everything happens automatically. Now, why I have just drawn only up to underlay, not like, if not above there is, let's say MPLS, you want to reach to data center, how do you reach and all. So that's a different story altogether that we will go in detail when we are actually starting our batch. But this is just an overall idea how the SDA access architecture looks like, and how you can actually see the magic about automation or the DNAC controller, how does that configuration happens, everything. Now, let me go back to our original presentation. Now, why SDA access is important, right? This is all about what SDA access I was telling, and automation, everything, what is DNAC, what is underlay, what is overlay. Now, SDA access is been added into almost all the certification. So if you take CCIE Enterprise, you got section 2 as SDA access. You got CCIE Enterprise infrastructure theoretical topic. You got SDA access covered, as a part of theory. Then you got a wireless as a CCIE. You also have Cisco DNS Center as a part of the syllabus. You got a separate certification, which is intent-based networking DNA assurance. You got complete DNA assurance, which is the SDA-based certification. You got CCNP as enterprise certification, in which you got SDA access as a part of syllabus. So even though you want to do any certification, you have to learn SDA access. That's why it is very important to know what is SDA access, how do we implement it, how do you design, how do you troubleshoot. Now, let's say you understood so far what is SDA access, you understood why it is important. Now, why, for example, why do you want to learn? We have covered that as well. Now, when you want to join us, let's say, for example, you have decided that you want to join SDA access with us. What do you get out of this particular course? So first is course content. Now, if you go to, for example, there are many institutes or many providers are available in the market who are delivering SDA access trainings. They are actually focusing more on the deployment side, whereas what we are doing here, we have got a course content in such a way that you will be standing in a position to design SDA access network. So you will actually you will understand how do you create bill of material, how do you actually require, let's say gather the requirement from customer, what kind of information you need to gather, how do you capture those details? How do you start going ahead and creating a document for designing? How do you design an entire end-to-end Cisco SD access network? How do you implement it? And then, how do you troubleshoot it? So all the course contents will be provided to you. Course material will be available, and then you get a ESD access wireless. So there are labs available on a dCloud which will be utilized by us to show a demo to you, and as well as there is a simulation called EVNG which will be used for SD access. Let's say, for example, you want to learn Lisp, we will show you Lisp demo as well. If we will go through VXLAN demo, we will go through TrustSec lab, and then you will understand overall how the TrustSec works or how identity service engine works and everything. Now, these are the course content in our entire course. What exactly you will learn out of the Cisco SD access. You will learn about wireless LAN controller implementation, designing Cisco SD access network. All right, and if you let me go back to the the lab which I was telling. Just give me a moment. So basically, this is your DNS center controller, which we are accessing through dCloud. So there are many labs available online. You just need to create your account in dCloud site, and then you will be able to book your labs there. And then we are going to do the same thing. I'll be booking a lab here, and I'll be showing you a demo about a DNS center assurance. For the rest of the things, like for example, what is Lisp, how the control node works, what is VXLAN, I'll be showing in the EVNG lab. So EVNG lab is, I have created those topologies. So
I have a question on labs.
yeah.
Are you going to provide some lab workbook or something like what we can explore in dCloud?
Definitely. Yeah, I'll be providing your lab workbook. How do you actually access lab? How do you execute lab? How do you monitor, let's say, step-by-step guide, basically, in terms of going through the entire workflow. So these are the labs in my simulation. If you see TrustSec now, so TrustSec I have not covered in the webinar, but this is kind of other than Lisp, VXLAN, you got a very important layer, which is security layer, where you will actually have ICE implemented or ICE integrated identity service engine with SD access network, and you can push the configuration of security like security group tags and everything, and you will implement end-to-end TrustSec via DNAC. So this is my not through DNAC. This is just a TrustSec lab where I'll be showing you how TrustSec works, how SGT security group tag works. So I'll be configuring all the devices. I have endpoint nodes here on the left. You can see through SGT, I'll implement some policies, and then I'll show the demo how they are actually blocking those access or how they're permitted to get the access. So no more IP-based ACL. It is all about HGT-based policies. Then you got a Lisp configuration or a Lisp demo. So this is a simple lab, but we will do packet capture. We will show you how Lisp works. What is RLOC? What is like loopback, which I was showing you? That's nothing but loopback RLOC IP addresses. What is Lisp domain? What is mapping server? I'll be showing that as well. Then I got a VXLAN lab, which I'll be showing as a demo. So let me show you that as well. So this is my VXLAN lab where I'll be doing packet capture. I'll be showing VXLAN headers. I'll be showing you how the VXLAN works, how flood and learn works, multicast works. So these are all labs. I'll be showing you demo, and I'll be giving you these files so that if you have EVNG installed on your local machine or server, you can straight away start practicing it, and you can easily understand how Lisp works, how VXLAN works, how TrustSec works. So you got labs, you got online dCloud labs through which we will access DNAC. We will show you how DNAC actually monitors the devices. How do you deploy automation through DNAC? How do you actually, let's say, for example, assurance? How do you monitor Wi-Fi? Now, there are many features added into this. I'll not go in depth right now, but it is really good to know about all Wi-Fi related use cases in DNAC, and then you will actually understand the importance of your DNAC or wireless use cases in the DNAC. So that's about actual overall SDA basic. I know that there are many questions in your mind about how do you deploy, what is how do you start with, and where do I get study material, where do I actually start with, how do I actually understand Lisp, because so far I only know routing protocols like ISIS, OSPF, BGP, and now it's quite difficult for me to go into this kind of terminologies or protocols which are new to me. Don't worry, we will start from the scratch. This is I have contact details here. You can reach out through email. You can contact via this is the contact number. The course fee is 17,999, but we are giving a discount, 10% discount for next 15 days. So you will be charged 16,199 if you want to join with next 15 days. And I'll be providing you course contents. I'll be giving you all the documents which are required for example, how do you design? Now, when we say design document, which is low-level design document, when we say requirement gathering information, we will have questionnaire created. So we will go through that workshop like as if there is a real-time customer asking they want to deploy SD access, and we are gathering information. So we'll go each all the questionnaires. We will capture that. We'll prepare a document. We'll share document with you. So you will get a lot of details, a lot of course contents. You'll get recordings of each session, and you will get these labs as well on EVNG. I will actually go through dCloud. How do you access dCloud lab as well? So that's all for today. If you have any questions, you can ask now. If you have any question, I'll stop sharing now.
So I have a question, like how this course is aligned to certification related to SDA access.
Yeah, so I was going through the certification here, right? So if you can see this, let's say someone want to do CCI wireless, or let's say someone want to do CCI enterprise, right? So if they want to do CCI enterprise, they have to learn Cisco SDA access. They have to know about VXLAN, they have to know about Lisp, they have to know Cisco TrustSec, they have to get details about how do they monitor devices on DNS Center and all. So as a part of certification, Cisco SD access is added almost in every CCI module as well as CCNP. Okay.
And are you going to, can you help with some additional resources to get this exams cleared?
Like what?
No, some practice test or something like that.
Yeah. Further, let's say we finish this batch and we want to actually dig out more. Someone has stuck with some implementation in real time, and they are trying to get a help. Definitely, we are available there. If you can ping, it is not like you have ended or you have finished the course and we are actually closing there. We will have group created. We will be in touch. So in case any queries or any questions in between, in real-time deployments, you can always ask questions on the group. Will be available there. if you have a kind of a requirement where you're saying that, okay, you are stuck in kind of a scenario where you don't know exactly how do you implement wireless. Yes, we will be there to actually guide you how you can go ahead and ask appropriate questions, gather the information, and then accordingly proceed for design.
And if I seek for your help during my kind of real implementation or real projects, so maybe one-on-one assistance is required. So that would be chargeable, or how is it going to be?
If you are looking forward to getting help, I mean, let's say you want to get ST access related document, or you are not able to get some clarity on particular terminology or particular technology, or let's say you are not able to understand how Lisp works, even though we are giving you lab demo or you're practicing, but still you're stuck with somewhere in real time, not in the lab, we will be available there.
Okay, thank you.
Yeah. Any questions, guys? If not, I will stop recording